All right, so this is our first example for friction. We have a 50-kilogram crate is being pushed on a horizontal floor at constant velocity. Given that the coefficient of kinetic friction between the crate and the floor is mu k equals zero point 0.1, what is the push force F? So again, remember that constant velocity means that we don't have an acceleration. So let's do black. Means no acceleration. And because of that, the net force is equal to 0 because we know the net force is equal to mass times acceleration. If acceleration 0, net force is 0, which means we have balanced forces. So if I draw a free body diagram of this object, I have a applied force being because that crate is being pushed to the right in this picture. And then we have the friction force backwards, because it opposes the motion. We have the force of gravity down and the normal force up. Now, all of these forces are balanced. If I want to know what the push force F is, or the applied force, I know that that's just going to be equal to the friction force, because again, we're at constant velocity, forces are balanced. So applied force is equal to the friction force. My equation for the friction force is mu k times the normal force. And then here, I know since my forces are balanced in the y direction as well, in the vertical direction, that normal force is equal to the force of gravity. So that means my applied force is equal to mu k times the force of gravity, which of course we know is just mass times acceleration of gravity. So applied force is equal to mu k times mass times acceleration of gravity. Plugging in our numbers, force applied equals the kinetic coefficient of friction, which was 0.1. That coefficient of friction is unitless also, so it's just 0.1. Mass of the crate was 50 kilograms. And then we know that the acceleration of gravity is 9.8 meters per second squared. So 0.1 times 50 times 9.8, we get 49 newtons.